For code linting and formatting, Ruff has become a very popular tool in the Python community, and in this video we're going to dive into it and explore some of the features that it offers. Now Ruff is an ultra-fast Python linter and formatter, as it says here, and it's written in Rust. And if we look at the graph just below here, this is the linting performed over the CPython codebase, and this is using common linting tools such as Flake8, PyFlakes and PyLint. You can see how fast Ruff is in comparison to these. So while PyLint, for example, will take greater than 60 seconds to lint that codebase, Ruff, on the other hand, takes 0.29 seconds, extremely fast, and that's unbelievably efficient over a large codebase. So Ruff is 10 to 100 times faster than existing linters, and it's also faster than formatters like Black because, as well as linting, Ruff offers these formatting options, and it's installable via pip, and it comes with pyproject.toml support. And importantly, if you're replacing tools like Flake8, isort and Black, it has drop-in parity with those tools, so you can directly replace them with Ruff. And that's not going to have any unexpected side effects to your code. Now there's a bunch of other stuff here, I'm not going to go through it all, but basically Ruff is extremely popular at the moment, and it's actively developed and being used in major open source projects. For example, Airflow. It's also being used in FastAPI, Hugging Face, Pandas and SciPy, and many more. And some good testimonials here if you want to read those. Let's cross over to the GitHub page. You can see it's got nearly 30,000 stars, very popular package. In this video, we're going to work through some examples using a simple Python script, and later on I'm going to add Ruff to an existing code base that I have, just to see what kind of issues that it pulls out from that code base. So before we get started, don't forget to give the video a thumbs up, and if you want to support the channel, we have a Ko-fi link in the description. So let's get started. Now if we go to the GitHub repository and we scroll down to the README, we're going to go down to a section here just under the testimonials. It's a table of contents, and this has a getting started section. Now you can install Ruff using pip, so what I'm going to do is open up VS Code, and I have basically an empty directory here. It contains one file actually called script.py, and we've activated a virtual environment in Python. I'm going to paste that pip install command into the terminal, and we can execute that command in order to install Ruff. Now I already have it installed, but that's going to install it for you if you don't already have it in the environment. Once we've got it installed, I'm going to go back to the documentation, and let's scroll down here, and we're going to see some usage examples here. So you can use Ruff as a linter, and that's done by running the ruff check command. So if you want to check all of the files in the current directory and all the files in subdirectories, you can just run this in the directory that you're in. On the other hand, if you want to provide a specific path to some file or some set of files here with a wildcard, then you can also do that with the ruff check command. And the same thing is going to work with the formatter. So that is done with the ruff format command, but all of the same path examples are going to be applicable here. And as well as a one-off command that you can run, you can also use Ruff as a pre-commit hook via the Ruff pre-commit package. And if we scroll down, Ruff can also be used as a GitHub action. So a lot of different usage examples here, different ways you can apply Ruff in your different projects in Python. We're going to keep it simple in this video, and we're just going to look at using a script and running commands on the command line. So I'm going to open this script.py file here. And let me just close the sidebar here, we don't need to look at that. And I'm going to paste some code in here. Now what we're doing here is we're importing itertools, which is a module or a package in the standard library of Python, but we're not actually using it anywhere, we're just printing hello world here, so it's a bit of a useless import. But let's see what happens if we go to the command line after installing Ruff, and we run the ruff check command. Now we're getting some output here, and we have what's called a rule code here, and that's F401, and that's the unused import rule in Ruff. Basically, we're importing a module that we're not actually using within this module of code. So this linting example can identify things like this in your code where you have imports, for example, but they're not actually being used in the file. And this is actually very common. You might bring in imports to perform some actions in your code, but over time your code evolves. Maybe you move that code out to another place, but you forget to remove the imports. So the linting can help you identify those kind of issues and resolve them. Now, the way to resolve this with Ruff, if we clear the terminal, as well as running ruff check, which performs the linting, some of these rules have auto fixes available, and we can do that by passing --fix into the rule. So I'm going to run this now, and you can see that that has fixed the problem that we had here. We have removed the unused import, and we now just have the simple print statement appearing in the script. Now you notice the formatting here, it's just removed the import, but we've got an empty line at the start, and if you're familiar with the Python rules for formatting, it also expects to have an empty line at the end of the module. So what I'm going to do is run a different command here. So it's going to be the ruff format command. Let's clear the terminal and run ruff format. And that's going to format all of the files in the current directory and the subdirectories, as we saw earlier. and you can see that it's removed the empty line at the start of the code, and it's added a new empty line at the end. So that's fixed that, and it's formatted the file. Now if you're interested, what I'm going to do is go to the Ruff documentation, and there's a section on the left hand side here on the different rules that can be used in Ruff. Now Ruff supports over 800 linting rules, and these are inspired by popular tools like 𝗧𝗧𝗧𝗧𝗧, isort, 𝗧𝗵𝗽𝗍𝗧𝗧𝗧 and others. And by default, what Ruff does is it enables the 𝗧𝗧𝗧𝗧𝗧𝗧F rules and a subset of E rules, and it omits any stylistic rules that overlap with the use of formatters like black. So if we go down here, you can see all of the different rules. This is the one for the unused import that we just seen, so we're going to click that. This is derived from the PyFlakes linter, and this rule will check for unused imports. And this is bad, having unused imports, because it adds a performance overhead at runtime and it risks creating import cycles. And of course, they also increase the cognitive load of reading the code. If you have so many imports in a module and some of them aren't even being used, then that's not great when you're actually analysing the code yourself. So this kind of linting rule can help you prevent these issues. And if we go to the section on the Ruff formatter, the formatter is an extremely fast Python code formatter designed as a drop-in replacement for black. And that's quite important because black is extremely popular. It's used by a lot of good projects. And if you look at the left-hand side, you can see a section on compatibility with black. So it's designed to be a drop-in replacement for black. And specifically, the formatter is intended to emit near identical output when it's run over black formatted code. So this means it should be very easy to switch from black to Ruff without any side effects affecting your code base. Now I want to go back to the rules page here, so I'm going to go back and we're going to go to this rules page. So let's go down and look at some of these rules. We have the PyFlakes rules beginning with F, and if we look at the the sidebar here, you can see we have rules for Py code style, and these are prefixed by E and W. We have rules for McCabe, and I believe this is about cyclomatic complexity, but I could be wrong. If I am, let me know in the comments. We also have rules for isort, so these are brought over from the isort package for sorting imports here. You can get those and add them to your project. We're going to see this later on, and I'm not going to go through all of these, but we also have rules for the 𝗵8 naming conventions as well. So we're going to explore some of these very soon in the video. I want to go back to the code now, and I'm going to replace this code with another line of code just to see another rule. So you can see immediately in VS Code we have the yellow line underneath the statement here. So it's telling us that we have an F string without any placeholders, and I've actually got Ruff installed as a VS Code extension here, and you can see the rule name up here. It's F541, and if we go back to our rules page, I'm going to search for that just now, F541, and that is the F string missing placeholders rule. So Ruff is able to detect this, and that will also happen on the command line. So if I save this file and we run the linter with the Ruff check command, you can see that rule is appearing here. And again, it's an easily fixable rule. We can run the Ruff check with the -- fix flag, and it's going to fix that by removing the empty F statement. Now I want to move on to configuring Ruff here, so I'm going to go back to the tutorial section of this, and we're going to scroll down to the section on configuration, and I'll leave a link to this particular section in the description of the video. Now to determine the appropriate settings for each Python file, Ruff is going to look for a pyproject.toml file or a ruff.toml file. And also we have a hidden file here we can use called .ruff.toml. So I'm going to add one of these. Now we're only using Ruff in this project, so I'm not going to use pyproject.toml. Let's just create a ruff.toml file, and I'm going to copy the code from here, and we'll go back to our VS Code project. I'm going to bring back the sidebar, and I'm going to add ruff.toml to this project, to this directory I should say, and we're going to paste this code in here. Now one example of the configuration we can set is for the line length. I'm setting this to 79, and I believe the black default is 88. So we're setting a smaller line length here, and we also have a section for linting configuration. And again, I'm going to minimize the sidebar. So basically what's happening here is we're adding a rule using this extend select configuration. So by default, Ruff is omitting any rules that overlap with black, but we can override this behavior by explicitly adding rules. So there are two kind of key options here, key configurations you can set for Ruff. One is extend select, and that's going to extend the default selected rules. And in fact, let's go to the documentation for this. So we have a settings page here in Ruff, and if we scroll down to the linting rules that we have here, we have an extend select rule. That's the one we've used, and this is a list of rule codes or prefixes to enable in addition to those that are specified by select. So the default value here is an empty list. So to the default selected rules that are added by Ruff, you can extend that with whatever rules you want. And if we scroll down on the sidebar, we have also the select option. And this is a list of rule codes or prefixes to enable. Now prefixes can specify exact rules, for example F841, or you can enable entire categories by adding a prefix like F to the list here. So it's quite flexible about adding specific rules or sets of rules by using prefixes. Now the default value in Ruff is these four here. We have E4 and E7 and E9, and then we have the F rules entirely added by Ruff. So you can see that at the bottom, and you can extend that by adding more to the selection. But I think the best way to do this is to take extend select and add your own set of rules to that. So that's going to append the rules that you specify to that default selection from Ruff. I'm going to go back to the terminal here, and if we run Ruff check one more time here, we can see we have a new issue. So what we've done here is we've extended the default rules in Ruff, we've added a new rule to the list using the extend select option, and that is now being picked up when we run the linter with the Ruff check command. So let's see some more examples. Before we do, I'm going to change the line length back to 88, which is the black default. And I'm going to minimize the terminal. We're going to go back to script.py. I'm going to remove this code, and I'm going to write another piece of code here. And this is going to be a Python function. And just a warning in advance, this is going to be a terrible function in Python. You wouldn't want to write anything like this in your code base. It's just absolute rubbish. So don't write this code. But what we're going to do is we're going to run a few different things using Ruff to demonstrate things like 𝗵𝗳 naming conventions and some new rules that we've not seen already. So we have a function called isEven. It takes a number. We have a Boolean flag here called isEven that's not actually being used in the code below. And then we are returning true if the number is even, or false if it's not even. And at the bottom, we're just calling that and passing the number 2 in. We don't even need this line, so I'm just going to remove it. What I'm going to do is go back to the terminal. Let's clear out the output here. And we're going to run the Ruff check command here. Now notice that we are getting this code here, F841. So we have a local variable isEven that's assigned to, but it's never used. And again, this is something that might happen in your code base as it evolves over time. You might define variables such as Boolean flags, and then you change the code a bit later on, and you forget to remove the variable. So Ruff has detected that this variable here is not being used. We can actually just get rid of that. And when we rerun the linter at the bottom using Ruff check, this time we're getting back that all checks have passed. Now there are some issues with this code here. So one of them is the naming of the function. In Python, we shouldn't have capital letters in a function name, so that's going to be something we need to add to the ruff.toml file in order to pick up instances of that. Let's go back to the section on rules in Ruff, and what I'm going to do is on the sidebar, I'm going to look for the 𝗵𝗳 naming rules. So these rules here apply to 𝗵𝗳 naming conventions. For example, you have rules to detect invalid class names, function names, argument names that are passed into functions, and so on. Now to add every single one of these rules to the Ruff linter, what we can do is we can take the prefix in, and we're going to go back to the ruff.toml file, and we can add that entire set of rules to the extend select option. Now once we've done that, I'm going to go back to the terminal, clear it, and we're going to rerun Ruff check. And this time we're getting a new rule coming back here as an issue. It's the N802 rule that the function name isEven should be lowercase. And that corresponds to this one here, invalid function name. So the 𝗵𝗳 naming rules, this particular rule here is detecting that that function is not named in the format that's expected by 𝗵𝗳. And if you're wondering what the convention is, Python functions should have the snake case naming convention. So we can go back now and fix this. So let's go back to script.py, and we're going to fix the name of the function to use snake case. When we rerun Ruff check at the bottom, this time we're getting that all checks have passed. So we've named the function appropriately and we've fixed that issue. And there's also another set of rules we can add. So I'm going to go back here to the rule set. And on the left hand side, we are going to scroll right down, and there's a set of refactor rules. Now I've scrolled down, actually I think it's up here somewhere. And I finally found this after longer than I should have. It's under the 𝗫𝗚 section, and it's refactor rules. And these can be helpful for identifying issues in your code that could potentially be refactored into something that's more Pythonic or just easier to read and understand. So let's add this entire set of rules to the extend select option in the ruff.toml file. So as well as n, we're now adding the set of refactor rules. And this time I'm going to expand the terminal, and we're going to go back here to the script. Let's just take one look at this again, and you can see that this is now highlighted in VS Code, the else block, unnecessary else after return statement. And this is referencing one of those refactor rules. It's got the number 505. And the problem here, well, it's not really a problem, but the way to improve this code is to notice here that we're checking if a number is divisible by 2. And if that's the case, we return true because it's even. But then we have an else block where we simply return false. Now, if this statement does not evaluate to true, then we're always going to return false. We don't actually need an else block here. So we could potentially remove that else block. The functionality is still going to be the same, but this is more readable because it introduces less nesting, less indentation in the function, and you don't need to think in your head about if and else blocks. You just have a simple if statement, and if that's not true, we know exactly what we're returning. So I don't know, this is kind of a matter of opinion, but I'm going to go back to the way it was before, and if we run rough check on the command line, we're going to see the same issue here that we saw on VS Code. So again, the fix for this is simply to remove the else block, and if we clear the terminal and rerun the rough check command, all checks have now passed. Now this function could actually be written as a one-liner in Python, so if you want to pause the video and try and figure out how to do that, you can do that just now. But what I'm going to do is just remove these return statements, and all we need to return is this statement here. So we're simply checking here, is the number divisible by 2? If it is, we return true. If not, we return false in this one line of code. Now I'm going to minimize the terminal and paste some more code in here, and we're going to see that this all works with classes as well. So we can see the highlighting in VS Code. We have a class name here that should use the cap words convention. So we are starting a class with a lowercase character. That's not the convention in Python. And we also have this parameter, this argument to a function, or a method rather, and that argument should be lowercase. We shouldn't have capitalized parameters or arguments in functions in Python. So what I'm going to do now is run the linter, and again we can use rough check here, and we're going to see these rules. So the first one here, n803, the argument n should be lowercase, so we can fix this simply by changing that to lowercase n here. We're going to save that. And if we clear the terminal and let's one more time run rough check, we have another 𝗶𝗄 naming breach here, and that's that the class should have the capitalized convention, cap words convention, sorry. And when we do that and run the check command again, now we get that all checks are passing. Now I want to demonstrate one final thing before we use rough on an existing code base, and that's the isort equivalent rules. So what I'm going to do is go back to the documentation, and again we're on this rules page here, and we have a section for the isort rules, and these are prefixed by I. So what I'm going to do is again go back to the ruff.toml file, and I'm going to add the I set of rules into extend select so that we use these. And I have Django installed in this virtual environment, so what I'm going to do is go back to this file here, and I'm going to paste in some code. And these are some imports from Django and from itertools. And there's a few things to note here. So the format is wrong in this import, and we can see that if we hover over this in VS Code. We've got a number of issues that Ruff is highlighting here. So for example, the import is unsorted or unformatted. That is coming from the isort rule set. It's the 𝗖𝗵𝗽𝗏 rule. And we also have the rule that we saw earlier on. So we're importing these things, but we're not actually using them in the module. So what I'm going to do is go back here. Now, if you're familiar with isort, you'll know that the imports that come from the Python standard library, they're at the top of the file. And then any imports from third-party packages are underneath those, separated by a line. And then any other imports that you have from your own code base should be underneath the third-party packages. So what I'm going to do now is run the rough check command. And when we run this, we're going to get these errors here. So let's fix these. Now we're going to ignore this rule here. It's F401. Obviously we're importing things here that we're not actually using. And actually, while we're at this, we are going to go back to ruff.toml, and you can ignore a set of rules in this file as well. And that's done under the linting section by adding an ignore option, and that can be set to a list of rules. So we're going to ignore the F401 rule. So I'm going to paste that in here, and basically that's going to tell Ruff to ignore instances of unused imports. You wouldn't want to do this in a real project, but I'm just going to do it for now, just to ignore that rule, but also to show you how you can add rules to this ignore set. So let's go back to script.py and expand our terminal. And we're going to clear out what we have here and run rough check. Now we have the line 2 wrong, that's the E501 rule. And if we scroll up, we have the I001 rule from isort, and that's that the import block is unsorted or unformatted. So as I said before, the standard library imports should be at the top, The other third-party imports from packages like Django should be below that. Now we can fix this by running the Ruff format command. So let's go back here, and what we're going to do is give ourselves enough space and run the Ruff format command. Now actually what's happened here is that it's formatted the imports according to the black convention, but it has not reordered according to what isort expects with the standard library imports at the top. Now we can fix this by going back to the terminal here, and I'm going to run the ruff check command and pass --fix into that, and that's going to fix this by sending the itertools import to the top of the file, and the Django imports are below here, and they are now formatted with the black formatting. So that's how you can apply the import conventions in Django from packages like isort and black. We have standard library packages at the top, third-party modules are here, and if you had any local applications, for example from your orders app, you might want to import an order model, these would come below the third-party imports. Let's clear that out and let's move on. What we're going to do now is we're going to open a Django project. Now you don't need to know anything about the project, but it's going to be the Django and 𝗤𝗵𝗽 finance application that we've been building on this channel. So we're going to open that and we're going to run the Ruff linting and formatting on that project, and we're going to see what kind of output we're going to get. So I've got this project open now, and you can see we're in the views.py file. Now you don't need to know anything about Django really, we're just going to demonstrate how Ruff can help here. But you can see that during the recording of this series, these imports are absolutely ridiculous. They're all over the place, and I've not been paying any attention to these as the project has evolved. And this is where using something like isort or Ruff can be very helpful if you start applying these rules from the very beginning of a project. But what we're going to do right now is just run the default rules. We don't have a ruff.toml file in this application or this project. So when we run the ruff check command, we're just going to be applying the default rules that Ruff comes installed with. So let's run that ruff check, and we're seeing that all checks have passed. Now what I'm going to do is I'm going to minimize all of this on the left hand side. You can see we have a Ruff cache directory. What I'm going to do is add that ruff.toml file from what we've been doing before. I'm going to add that here. So let's create a file called ruff.toml, and I'm going to paste in the code that we had before. So we're using these different options from extend select for the naming conventions, for the refactoring, and also from isort. And I'm going to remove the ignore statement here. We don't need that. So what I'm going to do is just clear this out, and we're going to rerun the ruff check command, and we're going to see now that we have some output here. For example, we have some instances of line too long. And if you look at the very bottom here, you can see that 17 of these issues are fixable, and we can use --fix in order to do that. So what I'm going to do is just go back to views.py, and you can see all of the highlighting going on from Ruff here, and that's because these import blocks are unsorted or unformatted. So if we go down to the terminal and we run the ruff check command with --fix, we're going to see that that is going to reorder all of the imports. So the Django imports are at the top, our imports from the code base that we have, so local imports, they are down below that, and this entire file has been checked and some of these issues have been fixed. Now what we can also do is run the ruff format command. So let's just create an example here. So if we don't have two lines between the functions, when we run ruff format, that's going to fix these kind of issues. And you can see across the entire project that 18 files have been reformatted and 8 files have been left unchanged. So we're applying all of these changes from Ruff by running the linter with the ruff check command, and optionally we can pass the --fix flag to that to try and fix some of the issues. And we also use ruff format to fix the formatting according to the setup that we have in the ruff.toml file, or you can use pyproject.toml. Now one thing to note, when you run ruff check with the --fix flag, if we clear the terminal and we rerun ruff check without that flag, you can see that we still have some issues. So that fix flag is not going to fix all of the issues, because there are some things that are going to need intervention from the programmer. So what it can do is fix some of the easy issues, and then if you rerun the ruff check command, you can see some of the other ones that are going to need you to go in and actually fix these issues yourself. For example, if we have a line that's too long, that's something you can go in and fix. And again, we're seeing things like unnecessary else after return statement, and more of these above here as well. Here's one from the 𝗵𝗽 naming conventions. We have a variable called getParams, and that's in a test function. And the problem here is that ideally in Python, your variables are going to be in lowercase, and we are breaching that rule here. So you can choose to change that, or you could potentially add this rule to an ignore set. If you want to allow your project to have variables that contain uppercase characters in the names. And if we scroll up, we are getting some other issues. I want to see if we have any new codes here. I don't think we do. Let's keep scrolling up. Quite a lot of issues here for the developer to go in and fix. Here's an interesting one from the refactor module. So an unnecessary assignment to a figure before the return statement. So the issue here is that before the return statement, we create a figure object by calling a 𝗏𝗧 bar function, and then we just immediately return that. So the fix for this is, instead of creating a variable here, just directly return what's coming back from the function. So we could just return px.bar instead of assigning it to a variable and returning the variable. So again, that can possibly be something that comes down to the preference of a programmer or a team, but that is a rule that exists in Ruff, and you can ignore it if you want, or you can apply it to your project. So that's going to be just about all for this video. One final thing to note: if you do something like this on an existing project where you're reformatting and changing things because of suggestions from a linter, this is something you want to do in a single commit. You don't want to mix it into a feature branch or anything like that, because it becomes very hard to identify what has changed in the feature branch when you're also introducing all of these formatting changes and adding and removing imports and so on. So basically, don't clutter your feature branch with formatting and linting changes. Just do this once and commit it as its own commit, and then you can move on with different feature branches. So that's just a final thought. Thank you for watching the video. If you've enjoyed it, give it a thumbs up. And if you want to support the channel, we have a Ko-fi link in the description. Again, that would be amazing if you want to contribute to that. But thanks again, and we'll see you in the next video.